So, dear friends, in the last lecture, we have learned how to find the complementary function of higher order linear differential equation with constant coefficient. Now, today we will learn method of finding particular integral. So, method of finding particular integral. Particular integral. We know that we know that your given differential equation is of the form f of d y, and this is equal to x. Okay, and we have learned how to find the complementary function. So by putting f of d equal to 0, you can find the roots of auxiliary equation. Getting? Now, after auxiliary equation, the next step is to find the particular integral. This differential equation can be written as what? Yp, particular integral, that is what? Yp equal to 1 upon f of d. 1 upon f of d and into the right hand side, that is x. Okay, that is x, where 1 upon f of d is what? Inverse operator, where 1 upon f of d is an inverse operator. Inverse operator. Okay. Therefore, the particular integral is given by yp equal to 1 upon f of d into x, f of d equal to x. So here 1 upon f of d into x can be written as what? Integration. This can be written as integration of x and dx. Okay, if you integrate, then you will get the solution. Okay, now there will be the cases. Okay, so case number 1 we write here. Case number 1. Okay, if y equal to 1 upon d, y equal to 1 upon dx, then you will write particular integral pi equal to 1 upon dx, and this is equal to what? Integration of x dx. Getting? Now case number 2. Case number 2, suppose if you have y equal to 1 upon d minus m x, then this can be written as particular integral of 1 upon d minus m x, and which is equal to what? E raised to mx integration of x into e raised to minus m x and dx. What is the m here? Where m is the root of auxiliary equation. Getting? Now case number 3. Case number 3. So here instead of minus, if there is a plus, then what happen? If y equal to 1 upon d plus m x, then your particular integral will be pi, and this equal to 1 upon d plus m x, and this can be written as e raised to minus mx
mx integration.
integration of x and e raised to mx. Okay, and dx. Okay, so here if there is minus sign, so we start with plus. Okay, if there is a plus sign, then we start with minus. Okay, now what are the examples? Let's see examples. We take some small examples so that you can understand the concept. Examples. Okay, example number 1. See, if I write here 1 upon d, 1 upon d sine x, 1 upon d sine x, then you can write like this: integration of sine x and dx. What is the integration of sine x? Minus of cos x, minus of cos x. Getting? And if I write example number 2, 1 upon d square and x. Okay, so what happened, this can be written as 1 upon d into 1 upon d and x, and this can be written as 1 upon d. Okay, now but 1 upon dx can be written as what? Integration of x and dx. Why this? So because of this, 1 upon dx is written as integration of x. So this is equal to 1 upon d, and integrate this is what? X square by 2. Okay, now again 1 upon d can be written as what? Integration of x, but x is what? X square by 2. So this can be written as integration of x square by 2 and dx. Okay, now integrate this, so you will get x cube by 3, and 3 into 2, that is what? X cube by 6. I hope you understood this. Now let us do for another one. Number 3, example number 3. So 1 upon d minus 2. If you have 1 upon d minus 2 into sine x, then how to find the particular integral? See here, this can be written, this is of the form of case number 2. Okay, this can be written as e raised to, here what is the root? Root is 2. So e raised to 2x integration of x. What is x here? Your x is sine x. Okay, your x is sine x into e raised to minus of 2x. Okay, and dx. So this can be written as what? E raised to 2x. I'm write this as a systematic. So e raised to minus 2x into sine x and dx. Okay, so we will have direct integration formula to find the integration of this. So this can be written as e raised to 2x, e raised to 2x. So integration of this is what? We know the result of that. Result is very simple. So you will have the result e raised to, sorry, integration of e raised to ax and sine bx and dx, and this is equal to what? This is equal to e raised to ax divided by a square plus b square, a square plus b square into a sine bx minus b cos bx, b cos bx. This is the result. Okay, this is the result, and we will use this result over here. So here a is what? A is minus 2, and b is what? B is 1. So just integrate this by using this result. So you will get e raised to minus 2x. Okay, and divide by a square. A is what? Minus 2 square. Minus 2 square means what? 4. Okay, and plus b square. B is here coefficient of sign, that is 1. So 1 ka square, that is 1. Getting? And then a b x, a sin bx, a is your 1 and sin bx, sin b is also sin bx, that is sin x. Okay, and minus b, b is what? Coefficient of sine, that is 1, and cos bx, cos bx, that is cos x. Getting? I am using this result to evaluate this integral, and this can be written as simply, now multiply. So exponential function e raised to 2x into e raised to minus of 2x become e raised to 0. 2x and minus 2x become e raised to 0, and divide by what? Divide by 4 plus 1, that is what? 5. That is 5. See here. Here a. What is the a here? Here a is
-2
minus
होगा ना
2.
सर?
Yes, yes.
Yes.
Here a is what? Minus 2. Getting? A is minus 2. Now simplify this. This is minus of sine x and minus of cos x. Okay, and this can be written as what? E raised to 0 is 1, and I'm taking minus sign outside, so this become minus 1 by 5, minus 1 by 5 sine x plus cos x, sine x 2 times of sine x plus cos x. Okay, so in this way you can find the particular integral of the form 1 upon d minus 2 sine x. Getting?
सर
Yes.
सर उसमें सर u इंटू वी क्यों नहीं किए? साइन एक्स ई रेस टू माइनस टू एक्स था, तो सर u इंटू वी क्यों नहीं किए?
u into b रूल, अब से ये डायरेक्ट रिजल्ट यूज होता है ना, तो आप यहाँ पे अप्लाई कर सकते हैं, आप u इंटू बी रूल भी अप्लाई करके आप देख सकते हो। ठीक है?
ओके सर।
हाँ, तो इस तरह से इसको सॉल्व करेंगे। सिमिलरली यू विल हैव कॉस फार्मूला। ठीक है, लेट अस डू फॉर कॉस आल्सो। सो नंबर फोर, if you have d plus 2 cos x, then you can write this equal to e raised to, here plus sign, so we will start with minus sign, e raised to minus 2x integration of we write here e raised to 2x cos x dx, cos x and dx. Okay, now we will use the result over here. Which result? Since the integration of e raised to ax cos bx and dx and equal to e raised to ax by a square plus b square into a cos bx and plus b sin bx. Okay, so we will use this result over here. So just use the result. So this become, so this equal to e raised to minus 2x as it is, and integration of this. So integration of this e raised to 2x. Okay, here a is what? 2, and divide by a square, that is 2 square, means what? 4, and plus b square, that is 1 square, that is 1. Okay, and into you will have a cos bx, a is 2, cos bx means what? Cos x, and plus b sin bx, here b is 1, so we write 1, and sin bx, that is sin x. Okay, just simplify this, and this equal to just multiply e raised to minus 2x and e raised to uh, 2x, that become what? E raised to 0, and divide by 4 plus 1, that is 5, and into 2 cos x and plus sin x. So e raised to 0 is 1, so this can be written as 1 upon 5, 1 upon 5 2 into cos x and plus sin x. Okay, so in this way you can integrate it. Getting, if there is a integration of the type e raised to ax into into sin bx or cos bx, then you will use direct formula. Getting, I hope you understood this. Now the next is what? Standard cases to find particular integral. What are the standard cases to find the particular integral? So we write standard cases to find particular integral. Particular integral. Okay. If you know all these things, then you can find easily particular integral. Otherwise, you will face the problem if you don't understand this concept. Okay. Now, see here. In that, we will learn number one. When your right hand side, that is capital X, equal to e raised to ax, then what happen? Then your particular integral will be pi equal to what? 1 upon 1 upon f of d, and the right hand side is what? E raised to ax. Eh? And this can be written as simply 1 upon f of a, d replaced by coefficient of exponential function, 1 upon f of a into e raised to ax. But there is a condition, provided that provided that the denominator part must not be 0. Means what? F of a should not be 0. Otherwise this technique will not be applied. Okay. See here, if denominator part 0, then what happen? So if denominator is not 0, then you can use this formula. Otherwise, you have to go for the exception case. So if f of a means f of a equal to 0, then what happen? Then we put f of d equal to d minus a phi of d. Okay. Okay. Now we differentiating this with respect to d. Just differentiate this. So we differentiate with respect to d. So this give f dash of d, and this is equal to what? Apply u into v rule. So this is first, this is second. So first d minus a and derivative of second phi dash of d, and plus second, that is phi of d, and derivative of first, this is d, derivative of d is 1, and this is the constant is 0. Okay, so this is the derivative of f of d. Getting, now now put put d equal to what? D equal to a. If you putting d equal to a, then what happen? So this become f dash of a, and this is equal to what? F dash of a. If I putting here d equal to a, so a minus a phi dash of a and plus phi of a. Getting? So phi f dash of a, so this become what? A minus a 0. Okay, whole thing is 0, and plus phi of a. Okay, therefore you can write f dash of a equal to phi of a. F dash of a equal to phi of a. Getting? So what happened? So your particular integral will be, we move to the next page first. So therefore the particular integral is equal to 1 upon f of d e raised to ax e raised to ax, and this can be written as 1 upon f of d is what we put here, d minus a, d minus a, d minus a, and phi of d into e raised to ax. Getting? E raised to ax. But here we put it here d equal to a. Okay. So this can be written as 1 upon 1 upon phi of a, 1 upon phi of a into d minus a as it is. Okay. And into e raised to ax. Now integrate this. So integrate this after integration. So we will integrate. So this is what 1 upon 1 upon phi of a. Phi of a I'm taking outside. See here 1 upon d minus a e raised to ax is what? Integration of simply integration of uh, this is e raised to 1 upon phi of a can be written as, so 1 upon d minus a into e raised to ax can be written as what? Here minus sign. So here will be plus e raised to ax integration of e raised to minus of ax into x. X is what? X is this e raised to ax and dx. Just integrate this. So this become 1 upon phi of a, 1 upon phi of a e raised to ax, and this is what? E raised to 0, e raised to 0 and dx. Okay, so this can be written as 1 upon pi of a e raised to 0 means what? E raised to 0 is 1. So integration of dx is what? Simply x. Integration of dx is simply x. So we write 1 upon phi of a into e raised to ax into x. So but phi of a is what? We found f dash of a. Phi of a we found f dash of a. So this can be written as x e raised to ax divided by f dash of a. Getting? So if denominator is 0, so your integral, particular integral will be x e raised to ax divided by f dash of a. Okay. So in this way you can find the particular integral if denominator part is 0. Now see here, if there is a factor, if there is a factor, that is what? d minus a, is a factor, repeated twice, is a factor repeated twice, then what happen? Repeated twice, that is what? F of d equal to d minus a square. Instead of f of d minus a, if there is another factor, means what? D minus a square psi of a. Okay, then what happen? Then your particular integral become pi become what? X square by 2 factorial x square by 2. So here, if you're not confusing, here we write here phi of a. Okay, phi of a. So this is what? X square by 2 factorial 1 upon phi of a into e raised to ax. Okay, but phi of a is what? Phi of a, your phi of a is f dash of a. But how many times we differentiate? F double dash. So there will be F double dash of A. Getting? Okay. So if there is two factors, then we differentiate twice and replace over here. Getting? And so on. And so on. If there are three factor, then we differentiate three times and replace the value of it. Getting? Now number 2. When x equal to sine ax, and suppose f of d equal to what? Pi of d square. Suppose f of d is a function of d square. Then what happen? Then we write the particular integral pi equal to 1 upon pi of d square sine ax, and this equal to what? Simply replacing 1 upon pi of negative of a square. Okay, we replace, instead of d square, we replacing negative of a square, or just write sine ax. Okay, now example, let us see example how to find this kind of particular integral. Suppose if you have 1 upon d square, 1 upon d square plus 3 and sine 2x, then what? Then their particular integral will be what? Simply 1 upon instead of d we putting negative of 2 square here and plus 3 as it is. Okay, and plus 3 as it is, and write down sine 2x. Just simplify this. This is equal to what? 1 upon negative 2 to the 4 and plus 3 into sine 2x, and this can be written as uh, simply what? Negative of,
सर प्लस 4 होगा ना
नहीं नहीं नहीं
स्क्वायर है
नहीं,
सर
सी यार दिस इज द नेगेटिव ईयर ना, नेगेटिव का ऐसा नहीं मैंने लिखा, दिस इज नॉट 2 और ऐसा नहीं लिखा, ठीक है? ये ऐसा नहीं, इसका मतलब 4 होता है, ये केवल नेगेटिव पहले है और 2 का स्क्वायर है, ऐसा है, ठीक है? ये कंफ्यूजन नहीं पालने का, या इसको आप क्लियर कर लो. सो दिस कैन बी रिटन एज व्हाट? -1 1 upon -1, that is sine 2x, and this is simply negative of sine 2x. Got it? Yes or no? You got it?
यस सर
Now see here, if the denominator is 0, means what? Phi of d square is 0, then what happen? This is the exception case. Okay, the above method fails if denominator part is 0. We write here the above method fails if denominator is 0. That is what? Pi of negative of a square is equal to 0. Then this method is failed. Then what happen? Then again we integrate this. Then we will have particular integral pi equal to what? 1 upon phi of d square sine ax, and this can be written as what? Simply just multiply x and divide by derivative, take derivative of this f dash phi dash of d square, sine ax. Okay, If denominator is 0, then what happen? We differentiate the denominator by the operator d. Getting? A simple technique है. Similarly, number 3, when x equal to what? Cos ax, then what happen? Then we will have the particular integral pi, and this is equal to 1 upon this is equal to phi of d square and cos ax, and this can be written as simply 1 upon phi of negative of a square and cos ax. Okay. Now again denominator, if this denominator is 0, then what happen? So this method is fails when we can write if this method is fails, this method is failed, then what happen? Then we write the particular integral, pi, and this is equal to what? 1 upon pi of d square cos ax, and this equal to, we write x divided by pi dash of d square cos ax. Okay. So in this way you can find the particular integral of cos ax and sin ax. Let us see the example, then you can understand it better. Chalo. Problem. Example number 1. Find the particular integral. Find the particular integral of following. Okay. Find the particular integral of following differential equation. Chaliye, number 1 we will have d square plus 4d plus 4 plus 4 y equal to hyperbolic cosine 2x, and number 2 you will have d square plus 4 y, and this is equal to what? Cos 2x. Okay. Now number 3 let us see number 3. Your number 3 is d raised to 4 minus a raised to 4 y, and this equal to sine ax. Okay, let us see how to find this. Now solution of 1. What I have to find? I have to find the particular integral given differential equation. We first copy this. So given differential equation, what is that? D square plus 4d and plus 4 y equal to what? Hyperbolic cosine 2x. Okay. Therefore, the particular integral is what? We direct find particular integral, and this is equal to, we write 1 upon f of d. That is f of d is your this function. That is what? D square plus 4d and plus 4. Okay. And into what? Right hand side into x. That is what? Cos hyperbolic 2x. Getting? So this can be written as, see here we don't know here how to find the particular integral of hyperbolic sine or cosine. Okay, so we know the formula for hyperbolic sine and cosine. What is that? Hyperbolic cosine ax. What is the hyperbolic cosine ax? This is equal to what? E raised to ax and plus e raised to minus ax and divide by what? 2. This is the formula for hyperbolic cosine ax. Getting? Now we replacing this value here. So we write here 1 upon d square plus 4d and plus 4. So instead of hyperbolic cosine 2x, we write here e raised to 2x and plus e raised to minus 2x and divide by 2. Okay. Now multiply inside. So 1 upon 2 I'm taking outside and write down the bracket. So this is 1 upon d square and plus 4d and plus 4. Okay, into e raised to 2x. This is the first part, and plus second part 1 upon d square and plus 4d and plus 4 into e raised to negative of 2x. Okay, so there are two parts, so we just simplify now. So this equal to 1 upon 2. 1 upon 2. Now see what happened here. Just put the coefficient over here and take and see the denominator part is 0 or not. So if I putting here 2, so 2 to the 4, and here putting 2, so 4 to the 8 and plus 4. Now add them. So denominator part will not be 0 here. So directly put here. If denominator part is not 0, then you can directly put the coefficient e raised to 2x and divide by, this is what, 2 square plus 4 into 2 plus 4. Okay. So here, if denominator part is 0, then you cannot put the coefficient directly over here. Getting? There is the, then you have to go for the exception case. Now check here. Check here. This is what, e raised to, now put the coefficient over here. This is what, minus 2. Minus 2 square and plus 4d. This, just check it. So this is 2 2 square, negative 2 square and plus 4 and negative 2 and plus 4. So 2 to the 4, this is a 4 and minus 4 to the 8 and plus 4. See here, 4 plus 4, 8 and minus 8. This will what? 0. So we cannot put here directly. So for this, what have to do? We differentiate the denominator part with respect to d. So we write 1 upon, so e raised to negative of 2x as it is. Okay, we differentiate denominator, only denominator part we have to differentiate with respect to operator d. So we differentiating this, we will get 2, we will get 2d. Okay, and 4, derivative of this, that is what, 4, and constant is 0. Okay, but what, but you have to multiply by x on numerator. You have to multiply by x on the numerator because you are differentiating once. So we multiply on the denominator by x. Getting? Now again check. This is step. Now solve this. This is what? So your denominator is 0 over here. Okay. So that's why we have done this step. Now write 1 upon 2 e raised to 2x. Just solve this. 2 to the 4 and plus 4 to the 8 and plus 4. Okay, and plus here. Now check again. Now put here if denominator part is 0 or not. The coefficient, if I putting here, so uh, this is 2 plus 2, here 2, and instead of d we putting here minus 2 and plus 4. Okay, so what happened here? 2 to the 4. So this is what? Minus 4 and plus 4. Again, denominator part is 0 here. Okay, so what happened over here? We again multiply by x and differentiate the denominator. So multiply करोगे x से आपको क्या मिलेगा? So you will get x square. Okay, and denominator, we differentiate the denominator with respect to the operator d. So you will get only 2. Okay, 4 is constant, you will get 0. So e raised to minus 2x. Getting? And this equal to what? 1 upon 2. 1 upon 2, just simplify, e raised to 2x divide by 4, 4, 8 and 8 and 16. So 16 plus x square into e raised to minus 2x by 2. Okay, so which is require particular integral of the given differential equation. I hope you understood this. Have you understood?
So can you
Yes.
Yes, sir.
बहुत सिंपल है आपको। हाँ, अगर देखो यहाँ पे, देखो मैं हिंदी में थोड़ा बता दे रहा हूँ आपको। अगर आपको ये डिनोमिनेटर पार्ट वहाँ पे 0 होता है तो क्या करने का, इफ इस ऑपरेटर को डी से डिफ्रेंशिएट करने का, मतलब डिनोमिनेटर पार्ट, या एक बार डिफ्रेंशिएट किया तो ऊपर एक बार एक्स से मल्टीप्लाई करने का, अगर 2 बार डिफ्रेंशिएट करना पड़ रहा है तो ऊपर 2 बार एक्स से मल्टीप्लाई करने का। ठीक है, मैंने देखो एक बार किया तो एक्स से मल्टीप्लाई किया, ठीक है, और फिर से 0 हो रहा है तो इसको वापस डिफ्रेंशिएट किया डी से, और एक बार और न्यूमरेटर में एक्स से मल्टीप्लाई कर दिया। बाकी जो आएगा सो आपका पर्टिकुलर इंटीग्रल होगा। समझ गया ये? समझ गया
हाँ
आपको?
सर।
हाँ।
हाँ सर।
अगर
Yes, sir.
0 नहीं होता है तो आप डायरेक्टली पुट कर दो कोएफिशिएंट। अगर 0 नहीं होता है तो डायरेक्टली पुट कर दो। ठीक है, अगर 0 होता है तो ये आपको प्रोसीजर फॉलो करना है। ठीक है, चलिए अभी हम नेक्स्ट नेक्स्ट प्रॉब्लम पे मूव करते हैं। कौन सा है? डी स्क्वायर प्लस 4y, प्रॉब्लम नंबर 2। Number 2. So what is that? Number 2. First of all, we write the given differential equation as it is. Given differential equation. What is that? Your given differential equation is d square plus 4y, and this is equal to cos 2x. Okay. Now our job is what? To find the particular integral, pi, particular integral, and this can be written as 1 upon f of d. F of d, matlab f is the function of d. So this can be written as what? D square plus 4 into x, right hand side. Your x is this, cos 2x. Okay. So this can be written as what? Now put the coefficient over here. If I putting coefficient over here, then what happen here? Just put here, just check it. Coefficient is what? Negative of 2 square. Okay, instead of d we putting negative of 2 square and plus 4. So this gives what? Negative 4 plus 4, and this is 0. Okay, the coefficient here, the denominator part vanish here. So what happen? We differentiating the denominator and multiply x. Okay, so just differentiate this, just differentiate. So we first multiply x because we are differentiating once, and differentiate the operator. This is what? 2d, and this is the constant, so derivative 4 is 0. Okay, into cos 2x as it is. Okay, now what? This equal to x by 2, we taking as it is, and we write here 1 upon d cos 2x, 1 upon d cos 2x. Okay, then this converted as x by 2, And 1 upon d cos 2x is what? Simply integration of cos 2x. Okay, since you can write here, since 1 upon d x is equal to integration of x dx. Okay, you know very well. So this is what is the integration of cos? So x by 2, integration of cos is sine 2x, but divide by coefficient is what? Your coefficient is 2, so you will have ax sine 2x by 4. So this is your particular integral of the given differential equation. I hope you understood this. Yes.
Yes, sir.
चलिए. And number 3, what is the number 3? The problem number 3, that is given differential equation is d raised to 4 minus a raised to 4 y, and this is equal to what? Sine ax. Okay, now our job is to find particular integral of the given differential equation. So we write here 1 upon d raised to 4 and minus a raised to 4 sine ax. Okay, now put a instead of here d square, d raised to 4. So what happen here? You will get a raised to 4 minus a raised to 4, that is denominator part 0. So for this what happen? So we first multiply on the numerator by x and differentiate denominator by d, that is for 4 dq. Okay, this is the constant, so this will 0, and right here sine a x. Okay, so now this can be written as like this. So this is what? This is x by 4 d square 1 upon d sine ax. You can write like this, yes or no? But 1 upon d sine x can be written as simply integration of sine ax. Okay, so this is x upon 4d square, and this can be written as, we use this formula 1 upon dx equal to integration of x sine x. Here x is sine ax, so this is integration of sine ax. So we write this equal to x upon 4d square, x upon 4d square. What is the integration of sine ax? That is what? Negative of cos x, negative of cos ax divided by its coefficient. What is the coefficient of this? Coefficient is a. Okay, now so this can be written as what? Negative of a x by 4d into 1 upon d and cos ax. This can be written as like this, yes or no? See here, this is the denominator, no? So we write here denominator, not numerator. So we write denominator, this is 4 a. Okay, you got it? Now what? Instead of 1 upon d cos ax, we write just simply integration of cos ax. So we write here, so negative of x divided by 4 4ad integration of cos ax and dx. Okay, here dx will be there and dx. Okay, just integrate this. So this is what? X divided by 4 times of ad integration of cos ax is what? Sine ax divided by its coefficient of sine, that is a. Okay, So this can be written as negative of x divided by a or a square. That is what 4, sorry, a and a, that is a square. This is negative of x upon 4a square, and this can be written as 1 upon d sine ax. Okay, now integrate this again. So you will have negative of x by 4a square. So 1 upon d sine ax is equal to what? Integration of sine ax. Integration of sine ax dx. Just integrate this. So integration of sine ax is for negative of cos. So this will be plus. So x divided by 4a square, and this is what? Cos ax divided by a. So this can be written as simply ax upon 4aq, x upon 4aq cos ax. Okay, which is require your particular integral. I hope you understood it better. समझ में आया आपको?
Yes, sir.
हाँ, अब स्टेप जरा याद रखो, मतलब कि डिनोमिनेटर पार्ट वेनिश होता है तो क्या करना है आपको, बस बस यही टेक्निक आपको याद रखना है, बाकी कुछ करने की जरूरत नहीं है। डिनोमिनेटर पार्ट वेनिश होता है तो आपको एक बार वेनिश होता है तो एक्स ऊपर एक्स से मल्टीप्लाई करो और उसको डिनोमिनेटर को ऑपरेटर से डिफ्रेंशिएट करो, फिर इंटीग्रेट करो, इसी तरह से आपको करना है। ठीक है, तो और क्वेश्चन दो आपको करने के लिए, क्वेश्चन दे दो बट सर, क्वेश्चन दे दो होमवर्क के लिए। एग्जाम्पल्स ओके। सॉल्व the differential equation. Solve the following differential equation. Number one. Your number one is dq plus 1 y equal to e raised to x plus 1 square. Okay. Number two, your number two is d square minus 2d plus 1 y equal to e raised to x plus 1. ठीक है। नंबर थ्री, dqy by dx cube minus 3 d square y by dx square and plus 9 dy by dx minus 27 y equal to what? Cos 3x. Okay. So dear friends, what I have to do? You have to solve the differential equation. For this, you have to find first complementary function, then you have to find particular integral, then add them. Y equal to what? Yc plus yp. So that will be your solution. Okay, I'm not asking you find the particular integral only or particular or complementary function only. Okay, you have to solve the differential equation. Means what? You have to find yc and yp and add them both, so you will get the solution of your given differential equation. Getting? So this is the homework for you. So please do all this problem at your home.